Today I'm going to show you how to use timer to create movements on the user interface. First, we need to know what a timer is. I'll use an example to explain it in detail. This is just an existing project. I'm going to create a new form, add a Windows form. Okay, just call it form 3. This is just for demonstration purpose. Okay, I enlarge this form. The toolbox is right here. If you scroll down, you can see in the not in this common controls, is in the components group. At the very end, this object is called timer. If you just drag and drop or double click on it, a timer will be included in your project. You can see this timer at the lower left corner. Okay, the timer basically is an object that can generate interrupts or ticks, and at a fixed interval. Okay, you can adjust the length of the interval, make it a millisecond or a microsecond or a second, based on your need of the program. If I right click on this timer and show the properties, you can see there are only a few. Enabled false. By default, it is stopped. It doesn't generate any signals to the program. Okay, and the interval is in the unit is a millisecond. So 100 millisecond. A millisecond is a thousandth of a second. So 100 milliseconds is 1/10 of a second. And you can, if you make it 1,000, that will be 1 second. Every second, the timer will generate a signal, and your program will listen to this signal and to take some actions. So the actions will be the program that you write. Okay, you tell your program what to do based on each signal. So if every second there's a signal and you do something, it appears to the user that there will be some movement. Okay, the dynamic movement. And the name of the timer, that you need this name to refer to this timer when you want to change the properties of this timer. Okay, and that's the 3 most important properties that you should know about timer. Okay, let's just move this away. Okay, dock it on the lower right corner. Now what I want to show you is how to use this timer to move a picture box in this form. First, I'm going to put a picture box. I will go back to this common components. Okay, picture box. I put a picture box on this form, and I click on this little triangle to choose an image. Okay, remember in the earlier example, I already imported some images into this project. And if you don't know how to do this, you just click on this import button. Okay, then this file dialog shows up. You choose an image that you want to import and just select open. It will go to your project. Then you can use it. Now I just want to use this Pikachu. Okay, and okay. So Pikachu is in my picture box, and then I need to adjust the size mode to stretch image. The entire image will be displayed in this picture box. Okay. Now what I want to explain is the coordination system of this form. For the Windows form, the upper left corner is the original point. Okay, so the x coordinate is 0 and the y coordinate is 0. So from this left up corner to the right, the x coordinate value will increase, and from the top down, okay, the y coordinate value will also increase. So this is a little bit different. In the regular coordinate system, and the original point is in the lower left corner. So for this form, you have to, in any programming environment, you have to remember the original point is on the upper left corner. Okay, so is the so it's the any object. So the position, for example, this picture box, we move it anywhere, we can see that there is a properties called the location, right? Let's see the location. You can see the location is 513 and 119. So how is this location determined? It's determined based on the upper left corner, okay, of this picture box. So it's this one right here. For example, if I move it to this point, it will become 0, 0, 1, 1, right? It's not exactly 0, 0. Then move a little bit, it will become 0, 0, right? It's 0, 0 now. And so now we understand the coordination system of this form. We will be able to move this picture box around. Okay. Now, what I want to do is to create a method associated with this timer. Remember, the timer generates a signal every interval. Okay. At every interval. Now we double click on this timer. You can see a method is called a timer 1 tick. A tick is a signal. Okay, so tick tock tock. That's how the clock goes. So every tick, whatever you write in this method will be executed. Okay, so what do we want to do? Well, at the beginning, we just want to do a very simple thing. We want to move the image from left to right. Okay, so I want the picture box. And how do we move the picture box? We just move the location of the picture box. The location, the X location, okay, the horizontal location is determined by a property called left. Left is the X coordinate value, okay, the value on the x-axis in the coordination system. And we want to use plus equal, which means we will add the value to this, the previous value of the left. We want to make it like 10, okay, so 10 pixels or 10 points, okay, 10 points. So that's it actually. Okay, now well, at the beginning we want to make this timer enabled. So by default it's disabled. Okay, so if we make this true, when the program runs, your Pikachu will start to move. Let's see. We need to change the startup form to this form 3. Now it's still form 1. Okay, now let's you see it's moving every second. It moves from left to right by 10 points. Okay, if you want to make it move a little bit faster, how do you do that? You can do it in 2 ways. Okay, the first is you can make the interval of the timer smaller. Now it is 1 second. We can decrease it to 100. So now it's 1/10 of a second. It will be very fast. Or you can increase the step size of the movement. Now we use 10 points. You can put like 20. It will be doubled. Okay. So now let's just use this approach to decrease the interval of the timer. And now let's run this. Okay, it moves very fast. Okay, Now let's see. Oh, now we have a problem, right? It just goes away, goes out of the boundary. So this has to be fixed. We have to make the Pikachu smarter than this. Okay, how do we do that? We need to make some decisions. Let's see. So now when the Pikachu hits this right boundary, we need to know about it. Okay. So the form has a property called the width, you know. So the left line is 0, and the width is the the position of the left boundary. So whenever the picture box right boundary hits the form's right boundary, you know that there's no way to go. Pikachu has to turn back. Okay. So now let's just to make a Pikachu recognize where the wall is, and when it hits the wall, it simply stops. Okay, then after we can do that, we'll figure it out how to make Pikachu turn around and go back. Now let's still open this timer tick. Okay, so how do we know that the wall is hit? We need to make a decision. If it's picture box dot left. Okay, so this is the location of the picture box, but we want to know the right boundary. We need to add the width of the picture box. Width. This will be the left boundary of the picture box. Okay. This is a little bit tricky. You have to spend a little bit time to figure it out here. And if this is greater than or equal to this refers to the form itself, okay? Width. So this is the right boundary of the form. If this is true, I mean this condition is met, which means the wall is hit, okay? And we want to stop the timer. Timer 1 dot stop. Okay. Once timer 1 is stopped, else nothing will, the picture box will stop moving. Otherwise, if this wall is not come across, then the picture box will keep moving. Now let's check if this works. Once it hits the wall, it should stop. Okay, it stopped. This is good. If we, okay, because the timer is stopped. Okay. Later, it will become smarter if the timer is enabled. Even you dynamically change the size of the form, the Pikachu will recognize his territory is enlarged. He can still moving. Okay, he will keep moving until a wall is hit. Okay, now Pikachu can recognize where the wall is. Now what we want to do is to make it turn around and comes back. So how do we do that? We need to have a first an easy mistake is just to decrease this by 1, right? Instead of stopping, now we want to make it turn around. We don't stop the timer. So what do we do? This is a common mistake. Okay, I want to show you this. Left minus equals to 10. This makes sense, right? At the beginning, we want to increase the position by 10. It will move to the right. Now, if we minus 10, it will go to the left, right? This seems make sense, but let's check if it works. Now it hits the wall. See what happens. okay, it goes crazy. It just keep bending itself on the wall. Okay, so obviously something is wrong. Why? Because only after this condition is met, it will minus 10. Otherwise, it's still plus 10. It's still moving to the right. So we have to make the, to set a signal outside this method. This is similar to the the toilet, bathroom on an airplane. Okay, when a person is using the toilet, the light is on. Okay, it is taken. And so similarly, you have to set a signal for picture to see which direction it should go. Okay, at the beginning it goes to the right. Once the wall is hit, you need to reset the position to left. So Pikachu will keep moving left without going to right again. Okay, so how do we do that? We need a class level data member right here. Okay, we need to set a private data member. We call it a string. We can call it h direction. Okay, direction. We can set the default value to right. Okay, so at the beginning, Pikachu will always go right. And here we also need to make some changes. After the wall is hit, we will not do this. Instead, we will reset the direction. So this V direction, H direction. Okay. Now it should be left. Okay. And else, which means there's no else. Okay. It's just the wall is hit. Once the wall is hit, we set the direction to left. Now we want to move the Pikachu, but every time before it moves, we have to look at the signal, the sign, to see whether the direction is left or right. Okay, so if each direction is left, then box left should be minus equals to 10. Okay, else, which means h direction is to the right, this dot picture box dot left plus equals to 10. Okay, if you are not sure what this is doing, just write a few more. Right, else means h direction is right. Okay, this is how you do it. Now let's check. So it hits the right wall and bounce back, move to the left, and now see what happens. Does it bounce back on the left? No. So there is something missing, right? So what's missing? Can you figure it out? Well, you can stop here if you want to figure it out. But next I'm going to tell you how to fix this. This is because you need to check whether the left wall is hit. How do you do that? Simple. You also check picturebox.left. But this time you don't need to add the width of the picture box, because now it is the left boundary of the picture box hit the left boundary of the form. Okay, it should be less than or equals to 0, because the left boundary, the x value is 0. Okay, now once this is true, you have to set the direction to right. So now Pikachu will move right to the right. Okay, now let's see if this works. Move to the left, bounce back, okay, and move to the left. Now if I dynamically change the size of the form, Pikachu is smart enough to recognize this. So once the wall is hit, it will bounce back. Okay. So that's the first step. So I just show you how to move an object on your form.